What's up, everybody? So the weathering lab. You were absent for the weathering lab. All I'm going to do here is give you a couple of quick vocab words. I'm going to go fast on this video. You'll probably have to pause it to write them. But if you write this in the beginning of your lab notebook, then as you start doing the 4 different experiments for this lab, when you try to pull it all together, trust me, having this little bit of vocab is going to be helpful. All right? So, weathering is the breakdown of Earth's bedrock, and that's all we're going to try to imitate in this lab. Only we've got to come up with ways to do it on a time scale that works, because we can't watch this over like thousands of years. We got to do this in the lab period in high school, right? So keep that in mind as we do it, that this is what we're talking about. Now, this is a review of what we did, last week. So those 2 types of weathering, like physical, breaks things into bits and makes sediments, whereas chemical works on a molecular level. This sentence sometimes scares people, but it's really a simple idea. If you've made Kool-Aid, you put sugar into water, you stir it, and it dissolves, right? Kool-Aid is a sugar solution. In nature, soluble rocks that dissolve, go into solution. Like salt water is a solution in the ocean, right? And that happens by chemical weathering. So again, pause here, write those down quick if you want. Or no, not if you want to do it. And then 2 more, and we'll get you out of here and get you started on the labs. Surface area is a concept that's going to come up a bunch. If you take something and like some rock that's this big, like this ball of twine. I don't have a rock in front of me, right? But if this were a rock and it's this big, weathering can happen on the outside of it. But if I were to break it in half, I would expose new surfaces and increase the surface area. I'd expose more to the elements. So what do you think? What would that do to the rate of weathering? And then lastly, the concept of abrasion is the idea that rocks and sediment wear each other down. Really, it's not by running water necessarily. It's the running water that moves the rocks and they all bang into each other. You could put something under a sink and nothing's going to happen to it. But put it in a beach with running water where the waves are coming in and coming out, coming in and coming out, and they boom, 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 over and over again. And this is what happens. Now, these are bricks. They're not rocks. But I use them very deliberately. And I've found these through the years on the shoreline of Lake Ontario, over towards my neck of the woods, where there's cobblestone beaches rather than sand beaches. Because we all know what a brick looks like. Like, we can envision this process. For some reason, somebody threw a brick into Lake Ontario. It's been stuck on the shoreline, and it's hit other bricks and other rocks over and over and over again until it gets rounder and smoother and rounder and smoother. So even though they're not rocks, it's the same process, just to help you see how that works. All right. So bang back through this. Make sure that you got all those vocab words in your book, and then you're ready to go with the 4 experiments that have pretty specific instructions. I'll get you. All right. Good luck, everybody.